Purpose of this video is to do an introduction into the introduction to Newton's second law activity. So our situation is going to be, we're going to have a ramp, which you'll see later, the actual ramp. We're going to have a ramp with a cart on it, and on top of the cart is going to be a force probe, which we used in our gravity lab. The string is going to be tied to the force probe. That's an F sub T for tension. There'll be some friction. These are supposed to be frictionless carts, but those don't actually exist, but it's a very low friction cart. There'll be a little bit of friction pulling back against the cart. We're going to have a weight hanging here. The force of gravity is going to pull the weight, and the pulley is going to just transfer. We've got a force pulling down, and with the string, that means the same force pulling down is going to be pulling this way, although there'll be a little friction in the pulley. So what we're going to do, we're going to use this force probe to measure the actual force that's pulling on the cart force probe combination. Now Newton's second law actually deals with the net force. The net force is what happens when you take all the forces pulling to the right, subtract all the forces pulling to the left, all the forces up, all the forces down, and you find out how much force is left. There's no difference between pulling 20 to the right and 10 to the left is the same as just having 10 to the right. So my net force in this case is the force on the string minus my force of friction. Okay. Now we're going to assume that our force of friction is 0 and then see how close our results are. Now in our previous lab we saw that the force of gravity was equal to mg, and then we extended that to say that the force, any force, is equal to the mass times the acceleration, but it has to be the net force. So we're going to ignore the force of friction, and that will be the error that we have in our lab. You're going to have a table that's going to have the mass. The masses will be given to you. We're going to measure the force with the LabQuest, and you'll see the details of that in the other videos. And we'll measure the acceleration with the second LabQuest. So we're going to have two LabQuest set up. Then when we get our data, we're going to make a force acceleration graph. So if our force is our y-axis, that's y equals mx, so F equals ma. That means the slope of this line should give us the mass of the cart and force probe together. And we'll see how close that comes out to be. Now the friction if the friction is constant, the slope should still work. If the friction gets bigger as we continue, as the friction gets bigger, as I add more weight, then it'll mess up our data a little bit. But if we take the slope of this line, if the force of friction is constant, then our line will be up a little bit, but we'll still have the same slope. So we'll see how that goes.